Okay guys, so today we're learning how to solve a quadratic by factoring. So the last 2 days we've been learning how to factor so that we can actually find solutions to these quadratics, okay? So I've given you kind of what a solution is at the top of these notes, and the first way that we have to solve a quadratic is to factor it. So we had to learn how to factor in order to find the solutions today. So that's what we're going to do. We're going to take each one of these problems as if it's a problem we've been doing the last few days, and we're going to factor it. And then we're going to use our factors to find the solutions, okay? So look at number 1. In order to factor it, we're looking for 2 factors of 3 that add up to 4, right? So this is when a is equal to 1. Now notice on all of these problems, we've got equals 0 at the end of them now. That means that now it's actually a function that we need to find a solution for, okay? So when you have equals 0, they want you to find solutions. They don't want you to just stop at factoring them. So we're going to have to factor first, and then once we find the factors, it's really easy to get the solutions, okay? So what are 2 factors of 3 that add up to 4? Well, 2 factors of 3 that add up to 4 would be 3 times 1. So my 2 factors are x plus 3 and x plus 1. Now, to go from here, these are called the factors, to finding the solutions, you have to set each one of these parentheses equal to 0. Actually, let me rewrite that. Okay, so you have to take x plus 3 and set it equal to 0, and you have to take x plus 1 and set it equal to 0. And then we solve to find what the x value would be. So we would subtract 3, and so x is going to be equal to negative 3. We would solve on this one by subtracting 1, and so x would be equal to negative 1. So our 2 solutions are negative 3, 0, and negative 1, 0. Okay? Now I write solutions as ordered pairs because a solution is also called an x-intercept. Okay? So when they ask for a solution, they're asking actually for an x-intercept. And so when we find these, we're finding the 2 places where this particular function hits the x-axis. So I'm going to write them as x-intercepts. Now, these are solutions. These up here were factors. Okay, so what we've been doing the last few days are called factors. If I want solutions, I have to take it a step further by finding which x value makes this equal to 0. Okay, so if I put a negative 3 up into this equation right here, if I put a negative 3 right here, I'm going to end up getting negative 3 plus 3, which would make 0. And 0 times anything is going to be equal to 0. If I put a negative 1 right here, negative 1 plus 1 will make 0, and 0 times anything will give me 0. So these are the 2 numbers that will make this particular function be equal to 0. Okay? Let's look at number 2. In number 2, again, we're trying to find 2 factors of 9 that add up to negative 6. Okay, so if I want positive 9, then I'm going to have to do negative 3 and negative 3, because negative 3 times negative 3 is 9, and negative 3 plus negative 3 is negative 6. Okay, so those are my 2 factors. Now I want to take it a step further to find my solutions. So I'm just going to take what's inside the parentheses, x minus 3, and set it equal to 0, and I'm going to do that both times. But if you notice, I'm going to get the same answer, obviously, right? So this is a situation where we actually only have 1, okay, because they're the same number. So we have 1 solution, and it's at 3, 0, okay? All right, if you notice that the 2 problems ahead were equal to 0, they always have to be equal to 0, okay? So on this problem, the very first thing I need to do is I need to add 4 to both sides so that I can make this look like standard form. Standard form has to have all 3 on the same side. So the A, the B, and the C all have to be on one side of the equation. So in this problem, the first thing I had to do was bring that negative 4 to the left side by adding it. Now I can factor like normal. So I'm looking for two factors that multiply to give me 4 and add up to negative 4. Okay, that's going to be minus 2 and minus 2. So again, this is like the last problem where we're going to end up having two of the same answer because we have two of the same binomial. So x is going to be equal to 2. X over here is going to be equal to 2, and so I really only have one solution. All right, number 4. Notice this is not a trinomial. This is a binomial, and they've got something in common. So we're actually going to use GCF on this one. So my greatest common factor is going to be a 2 and an x. And when I factor that out, I'm going to be left with an x, because 2x times x makes 2x squared, and then a minus 8, because 2x times negative 8 makes negative 16. Okay? Now, this one right here, the 2x, is just like it has parentheses. So you're going to do exactly what you did with all the problems before it. You're going to take 2x and set it equal to 0, and you're going to take x minus 8 and set it equal to 0. So if I divide by 2 here, I'm going to get that x is equal to 0. And if I add 8 here, I'm going to get that x is equal to 8. So I have two answers. One solution is at 0, 0, and one solution is at 8, 0. And again, remember, these are called x-intercepts. Solutions are the exact same thing as an x-intercept. All right, problem number 5 is one of those that has an a value greater than 1. So we're going to remember, take a and multiply it by c. So that gives us 8. And we're looking for two factors of 8 that add up to negative 9. So that's going to be negative 8 and negative 1, right? We don't write the middle term. So we're going to write 2x squared minus 8x minus 1x plus 4 equals 0. Remember, you don't write the middle term, and instead you write the two numbers that you multiplied to get negative, or to get positive 8, and that added to get negative 9. Now we're going to group them. Okay, so the first two are going to be grouped together, and the last two are going to be grouped together. Now we're going to do the GCF. So 2 and an x, leaving you with x minus 4. Okay, because 2x times x gives you 2x squared. 2x times negative 4 gives you negative 8x. And then over here, they just have a negative 1 in common. We're going to take out a negative from that because we want, remember, the two binomials to be the same. So we have to take out a negative 1 so that this can be an x and this can be a minus 4. Okay, so that gives us 2x minus 1 times x minus 4 when we factor that. Now to find the solutions, you have to set each one of these equal to 0 and solve. Remember, these are just factors right here. These are going to be your solutions. So x over here is going to be equal to 4. And then if I add 1 and add 1, extend this, we're going to end up having 2x equals 1. When you divide by 2, you'll get that x is equal to 1/2. So my two answers are going to be 1/2, 0, and 4, 0. Okay? All right, and then number 6, notice that it is a difference of two perfect squares. We have x and we have 9. So remember, we're going to do x plus 9 and x minus 9 equals 0. Again, those are the factors. We have to now find the solutions by setting each factor equal to 0. So x is equal to negative 9, and x is equal to positive 9. So make sure you write them as intercepts. Negative 9, 0, positive 9, 0. Okay, the last problem we have is a word problem. Okay, it says a rectangular garden measures 10 feet by 15 feet. Okay, so we have this rectangular garden that measures 10 by 15. Okay? By adding x feet to the width and w feet to the length, the area is doubled. Okay? So this is supposed to be an x as well. You're adding the same amount to both sides. Okay, so it says that if I add x amount here and I add x amount here, I get a new one, right? And the area is then doubled. So think about what the area is for the red. The area for the red is 150, right? So the area for the blue is going to have to be 300. So now, the new width and length have to be x plus 10 and x plus 15. Okay? So, if I need to figure out the function of the area, I'm going to do x plus 10, that's my length, times x plus 15, that's my width, equals my new area, which is 300. Okay? All right, so now what's going to happen is we've got to write it in standard form so that then we can solve for x. So we have to multiply this out. Okay? I'm going to do this out to the side. This is going to be x squared, 15x, 10x, and 150. Okay? So this is going to end up being x squared plus 25x plus 150 equals 300. Don't forget that equals 300. Now, in order for us to find a solution, we have to have this equal to 0. So we need to subtract this 300 to the other side. We're going to end up having x squared plus 25x minus 150 equals 0. Now we can find our factors so that we can then use one of the factors to find a solution. So we're looking for two numbers that multiply to give us negative 150 and add up to 25. So I'm going to give you a few minutes to think about that. Okay, so the most obvious one that you guys are going to think about is 15 and 10, I'm pretty sure. The problem is 15 and 10, no matter how you make that work, isn't going to give you 25 if you have to have one positive and one negative. So instead, you need to think of a different set. Okay, and the different set that you're probably not thinking of is 30 and 5. Okay? If I need a positive 25, then I can do a negative 5 and a positive 30 and get 25. Okay? So now to find my solutions are going to end up being a negative 30 and a positive 5. But here's the problem. If we're talking about a width and a length, you can't have a negative number. So this particular answer is thrown out because it's not doable for a width and a length of a rectangle. So our only answer is 5. And that means that is our width. Okay? Our width is equal to 5. And so now we have to go back and figure out, actually that's our x value, my bad. That's our x value. We have to go back and figure out our width and our length. So remember, one of them is x plus 10, which would be 5 plus 10, which is 15. And one of them was x plus 25, which would be 5 plus, I'm sorry, that was a 15. Okay, so x plus 15, which would be 5 plus 15, which is 20. So your dimensions would be a 15 by 20 rectangle. Okay, so today you should have learned how to solve a quadratic by factoring. We are going to learn how to solve these things by several different ways, but the first way that we learned is by factoring. And factoring means that we have to find parentheses, right? We got to multiply two parentheses. Sometimes we have to go through, when a is greater than 1, we have to factor it the way you learned yesterday. Other times it's a equal to 1, and it's just really easy to play the number game, okay? And then sometimes there are special cases. There's dots, or there's greatest common factor. But the bottom line is, once you factor, you're going to take your factors and set each of them equal to 0 and solve for x. And when you get that x value is your solution. You will have 1 sometimes, you will have 2 sometimes. Remember that a solution is an x-intercept. So we write it as an ordered pair with a 0 because it's where it crosses the x-axis. See y'all tomorrow.